Welcome back to SN Tutors. Today we're going to be talking about more physics for our physics module, specifically today, energy transfer. So there are three main types of energy that you're going to learn about in your physics course. The first one is gravitational potential energy. So if I have a block and it goes from point A, which would be right here, we'll just call that A, down to point B, which is here. Let's just say it slides down a ramp, right? So then if the height of that ramp is h being the vertical distance, this distance here, then we can represent the energy lost in the gravitational sector, or whatever you want to call it. So the energy difference between A and B is mgh. So I'm going to circle that. Where this is the mass of the block, this is 9.8 meters per second squared, and h is going to be this height right here. So delta E will be mgh of B minus mgh of A. But if you just call h here to be 0, then you could just call this energy difference mgh, right? So if this is 0 and this is h in terms of height, then the energy difference there is mgh. Now, where does that energy go though? If it's being lost, it's not being lost. It's being transferred from gravitational potential energy to some other kind of energy. Usually what's going to happen is it's going to have kinetic energy. So kinetic energy is energy which means it is now moving, right? So if it starts with a kinetic energy of 0 here, then here the kinetic energy is going to be 1/2 mv squared. That's mass and that's velocity. And that's going to be equal to mgh. Unless this ramp right here has friction, then you're going to lose some more energy in the form of work done by friction. But let's just say it's frictionless. Right, so then the third type of potential energy is for a spring, right? And that energy is represented by 1/2 kx squared. Okay, where x is the distance from equilibrium and k is the spring constant. And by equilibrium, that's the spring when it's not compressed. So distance from equilibrium is basically how much it's compressed, usually in centimeters, I believe. It depends on the units of what your spring constant is. Just make sure the units match. So distance from equilibrium, spring constant, and this ramp is frictionless, or else you're going to lose some energy and these won't be equal. And then, yeah, you could have a problem where they tell you that all the kinetic energy is transferred into the energy of the spring, and they're going to ask you how much it's compressed. Well, first you have to find mgh, set that equal to 1/2 mv squared, then you can solve. Well, you actually you don't have to solve. If they're equal, you could just set mgh directly equal to 1/2 kx squared. If it goes down, if all of the kinetic energy gets transferred into the spring, then you could just solve for x, if you know the spring constant, of course, and that will tell you how much is compressed. So yeah, that's pretty much it for energy. Please let me know if you have any questions or comments down below. Thank you for watching.